Bismillahirrahmanirrahim. My name is Anam Aslam, and today my topic is transfer learning and deep neural networks. Coming towards the outline of the today's presentation, we are going to see about the deep learning, the transfer learning, and the third one is transfer learning in the deep neural network. What is deep learning? As written on the slide, like train networks with many layers, or we have multiple layers, work to build an improved feature space. As we know that in the deep learning we have some neural networks. We have some combinations of the neurons, and they are listed in the form of a layers, and each layer do some calculation, pass the result to the second layer, and the second layer pass the result to the third one, and so on. The result goes the result pass out to the to the next layer, and the result is produces. So deep learning, we can say that, like, confronted with an array of the pixels, no computer inherently knows the difference between a house, tree, and a cat. Deep learning is the guy with the paint brush in this image. We can you see this. The computer is unable to distinguish between the images, so we train each we train our models on each kind of images, and we so that it can identify the different type of objects in a one image. Now we talk about the combined features, that like local detectors, and the combined to, like, how we combined the different results and produce a single output. In the neural network, you know that we have we have many layers. In the deep learning, we have many layers of the neurons. So each layer has a specific task to perform, or each neuron can have a specific task to perform. Like each neuron has in the network, you can say that each neuron like have different tasks. One has to detect the nose, second one has to detect the eye, and third one has to detect the mouth. And all these neurons produce some kind of the output, and these output is combined and tested whether it is meet the threshold or not, and it produces the result like face. So you can say that in this like slide you can see this, we have some input data, we extract some features, and we produce some output. So the question is, can we learn the features from the data? Yes, we can learn the features from the data. We assign some numeric values to all the different kind of the feature, and we perform some mathematical calculations. We can use some logistics, regressions, or SVMs to identify the values, or to get the right value from the data. Here is some logistic regression example. Like this is we have some formulas, we have some input values. On these input values we perform some calculations, and the output is compared with the threshold value. This is a 4 layer network with the 2 output units. We have layer 1, layer 2, and layer 3, and layer 4, and some inputs. On the layer 1 some calculations are performed, the output is given to the layer 2. The output of the layer 1 is input of the layer 2, and it produces again some calculations, gives the output to the layer 3. So this is how the neural networks work out. The training of a neural network. How we train a neural network? We give some data set to the neural network. It performs some calculations on it and produce some output. We use the backpropagation algorithm here also, like in the given slide. Like if some errors occurs at layer 2, like it doesn't produce some calculations accurately, or the calculation or resultant values does not mean a threshold. So what happens, like we do some backpropagation, and we do the previous calculations again. so we can produce the right output. This is called the error finding or the back propagation. The goal is to achieve the threshold value, or goal is to achieve the accurate value from the data. So multi-layer makes sense now here. Like many layer neural network architecture should be capable of learning the true underlying features and feature logic, and therefore generalize very well. Here in the example you can see. But you can see that until very recently our weight learning algorithm simply did not work on multi-layer architecture. So how we can resolve this solution? The new way to train the multi-layer ANN layer is ANNS. So the new way to train multi-layer ANNS is what we do is we train the first two this first layer, the combination of the two layers, we train them first. Again we made the pair of the next two, train them. The third and fourth pair combinedly form a pair, and we again train them, so on we goes to the result. So deep leaf nets are probabilistic generative models. They are composed of the multiple layers of stochastic latent variables. The latent variables typically have binary values and are often called hidden units or the feature detectors. The lower layers receive top-down directed connections from the layers down, layers above. The states of the units in the lowest layer represent a data vector. So now coming towards the transfer of learning. As listed on the slide, the study of the dependency of the human conduct, learning or performance on the prior experience. Like the transfer of learning is very popular nowadays in image processing and NLP. Here we take images, train a model, and use its knowledge to solve other problems. Like in the previous models, what we used to do, we have a lot of the iterations, and we performed a lot of the iterations to carry out the to get the data. So now we have only 3 or 4 iterations as we are using the pre-trained models. Okay, so the Woodworth and Thorndike in 1901 explored how the individuals would transfer in one context to another context that share similar characteristics. Okay, the transfer of learning is the ability of a system to recognize and apply the knowledge and skills learned in the previous task to novel the task or the new domains which share some commonality. Okay, so the question here is, given a target task, how to identify the commonality between the task and the previous task and transfer knowledge from the previous task to the target one. So it is a very big question. So we have some positive transfers and we have some negative transfer. When learning in one conduct improves performance in some other context, it is called the positive transfer. Like for example, when we are going to for example, we have trained our model on all kinds of the cars. Now the task is to train to identify the truck, so we can use our previous knowledge to identify the new one. So this is a positive transfer. So, and negative transfer is when learning in one context has a negative impact on the performance in other contexts. It is called the negative transfer. So when we are using the previous model, so we have some kind of assumption, like training and tests are from the same distribution, training and tests are in the same feature space also. So this is how we with these two assumptions we use the pre-trained model to train the next model. Okay, When in the deep learning, you know that every time we have to collect a new labeled data in large amount and build a new model. So we decided, and we found, we discovered, we invented a new kind of technique, the transfer learning. So in this, what we are going to do, we reuse and adapt the already learned models. In this example, you can see that we have some buses, and see we have some trucks. We in the feature task 1, we have trained our model on this, and the second one, the feature task 2, we have trained our model on the cars and the motorcycles. But in this model 2, we reuse our feature task 1. They are also belongs to the type cars, like some type vehicles. Now we are going to use this previous feature task 1 to again to train our model. So comparing between the traditional machine learning and transfer learning, here you can see that we have to divide the learning on different tasks, and we have to perform the calculations on a large amount of the data. But in the transfer learning, what we are going to do, we have some source data, and in the transfer learning we have some source task and combination in the form of a knowledge, and it is given to the target text task of. So it like saves a lot of the epochs and iterations in the time when it comes to the transfer learning. Why a transfer learning? You can see this in some domains, labeled data are in short supply. In some domains, the calibration effort is very expensive, and in some domains the learning process is time consuming. So to cope up with all the kind of problems, transfer learning techniques may help a lot. In this, it is an overview and of the various settings of the transfer learning. You can see that transfer learning is divided into the 3 parts, like inductive transfer, transductive transfer, and unsupervised transfer learning. In inductive transfer learning, we have some labeled data available, and in transductive learning we have labeled data is available only in a source domain, and in an unsupervised transfer learning there is no labeled data in both the source and the target domain. That inductive transfer learning is again divided into the 2 cases, like case 1 and case 2. In the case 1 we have no labeled data in a source. In the case 2 we have the labeled data are available in the sources. Case 1 again we have some self-learning taught, and case 2 we have the multitask learning. The transductive learning is again divided into 2 parts, the sample selection bias and domain adaptation. Transfer learning is based on the pre-trained model. Here it is an example. You can see this. In this example we have an input image, we have some layers, input layer and hidden layers, and again the output is softmax, and like the last one is the softmax, and again the output produces going to make the 1000 of the classes. So what happens, we use some predefined data, and we pre-trained model to identify the images, and we just changed the last one according to our new problem. So this is how the transfer learning works out. Transfer learning is to reuse the source knowledge to help a target learner. In conclusion, we have these lines like transfer learning is to reuse the source knowledge to help a target learner, and self-taught learning transfer enabled features. What are the challenges to the deep learning? In the deep learning we can see that there is a lot of the training set, validation. Like in the training set we have 80% we have 80% training set and 20% validation set, and so the validation set is used to validate, and training set is given to the neural network to train out. So the output of the validation set again goes to the deep neural network, adjust the hyperparameters model architecture. So this workflow of the deep learning is going to be very complex. So the deep learning so deep learning has some pros and the cons, and we are going to discuss about them. The pros enables learning of the features rather than hand tuning, and its impressive performance gains on computer vision, speech recognition, and potential for much more impact. When we talk about the cons, computationally really expensive, requires a lot of the data for the high accuracy, extremely hard to tune, and choice of architecture. Again, it has a very complex architecture, parameter types and hyperparameter types. So we have to the selection of the parameters is very difficult in the deep learnings, and incredibly hard to tune. So when we the deep feature is we are going to apply the deep learning using the transfer learning. Instead of the training a deep network from the scratch for your task, take a network trained on a different domain for a different source task, adapt it for your domain and your target task. Here is an example, like source. We have some source data, train some source model, and some source labels. We are going to use this this knowledge transfer the learned knowledge to the next new model. Here you can see that we have some algorithm self-taught learning. In the self-taught learning, we have some built classifiers for the cars and the motorbikes. We use some formulas to carry out the self-taught learning out. And when we do some self-taught learning, we have some unlabeled data sets, and we have to achieve the high level of the features. To transfer the learning, use the data from the one domain to help learn on another. You can see that we have the lots of the data, learn the neural network, great accuracy. It will produce a great accuracy. And from the middle one, you can see that the learn the neural network. Again, we have some neural net as feature extractor plus simple classifier. We can achieve this thing with neural networks as well. What's learned in a neural net? We can see that we have some more generic it can be used as a feature extractor portion, and very specific to the task one. Like when we are going to reuse some trained model, we have some very common things, a commonality between the two problems. So for the commonality, we are going to use the previous trained model, and